Hello and welcome to video number 12B for the Foucault's Pendulum for Advanced Experimenters. I've chosen 12B because I didn't want to go to 13 till I'd cleaned up some of these, a bit of advice that I was given to by 12. Some comments were concerned about air movements and the launch index indicator position wasn't clearly marked enough. Basically, I agree with them that I didn't make that clear. Air movements could be possibly, or the string holding the pendulum may affect its trajectory as it moves through the air. So I didn't really address that. Also, I never had a compass reading. All our compass readings should go north-south, just like the one in Paris. Apparently all pendulums should be launched north-south because that is the best method to give the pendulum the most best trajectory to allow it to go around rather than east-west. I, however, will probably go back to do a east-west launch, as that was also some more advice by another contributor in the comments, which was great. Thanks for that. Also, I should have realised that I possibly hadn't duplicated the same ratio as the pendulum in Paris, which is 7:1. It's 67 metres long by 10 metres wide at swing. So we should be in that 7:1, which should be in that cosine of equals 1. So our ratio, horizontal to vertical, should be in this cosine 1. Also, between these two videos, you might have heard, it's quite a controversial thing has just happened, that the final experiment has been done by a group of enthusiasts who have gone to Antarctica and to a place called Union Glacier to do an experiment to test the 24-hour sun. Now, good on them. They're actually doing experiments, which is something I like to see, rather than armchair, and it would have been a very expensive trip. Now, excuse me, the only controversy that I have is, I just didn't get this bit. We know that the final experiment was done by Foucault in 1851. That categorically was the final experiment to put to rest whether the Earth was spinning, flat, or whatever. The pendulum solved that. So in 1851, the Foucault pendulum was the final experiment. All these discussions, like you might have, if you look at this flat Earth of the final experiment video, they were addressing the angle of the sun and was there a reflected image of the sun, which all been done in 1851. They predicted a 24-hour sun. Here where I live, I get 180 degrees or almost 12 hours of sun. Now, people in Chile, which is just about here, I'd say they're getting at least, 18 hours of sun. Probably even 20 hours of sun. I don't know what it is, I can't remember, but surely we knew that the South Pole was getting a 24-hour sun. So why they went there, I don't know, but conspiracy if you want to get into conspiracies, this is where I was a bit rattled by this one. The fact that they went to Union Glacier, however, the United States have a permanent base 100 metres from the actual ground zero South Pole. So why wouldn't they have just sent them a sundial? Or why wouldn't they just taken a photo of the flag, that ceremonial flag that sits in the South Pole, and watch the sun go around? Okay, look, I don't want to knock people for doing experiments, but hey. Right, so we have to go on with the pendulum. We can't stop. The pendulum was the final experiment. Don't get sidetracked, guys. So if you've been following me, don't get sidetracked. And also, please don't subscribe to my channel and don't hit the like button. If you like to do something, hit the dislike button. I don't want to be known. Keep me under the radar. Also, I don't think we were in an isochronous situation. Now, isochronous is where the amplitude, the frequency of a oscillation will remain the same, independent of its amplitude. So I think our first, in 12, I don't think we were in isochronous. So let's start again with 12B and just fine tune that with some more boxes ticks. So thanks again for these guys who commented, and that was grateful. So let's move on to the experiment now. So here's our pendulum set up, and our time is 18:53. Our pendulum is suspended by a optical cable illuminated by a laser beam to a magnetic coupling at the top. We have our two indicator marks. (300mm) apart, which will be the swing of the pendulum. Our swing direction is almost north-south, and our swing distance is being measured where the laser stops at this point here. So that's our datum point for getting constant swing distances. Over to our laser generator, and I'll just turn the other camera on. So here we are, ready to do our launch. Pendulum was away. Just looking at those air currents, there's virtually no air current there apart from what's swinging. If I blow on it, that would be a huge amount of air, but I'm in my lab, which is sealed, so there's no air, very little air current. However, I have an open mind that could be causing some drag. Our launch indicator is still in the same position as launch, clearly marked by that where the cotton string attaches, and that Sharpie mark on the side of the pendulum. So here we are, ready to do our launch. Pendulum was away. Just looking at those air currents, there's virtually no air current there apart from what's swinging. If I blow on it, that would be a huge amount of air, but I'm in my lab, which is sealed, so there's no air, very little air current. However, I have an open mind that could be causing some drag. Our launch indicator is still in the same position as launch, clearly marked by that where the cotton string attaches, and that Sharpie mark on the side of the pendulum. Right, we're 1 minute in. And the clock is 6:57. The pendulum swing is exactly how it was launched, and the laser is oscillating slightly. To the left. We're getting rid of deviation left and right. I didn't check where the launch, it should have been dead on accurate with the centre, but I didn't check that. Anyway, we'll just let it swing for a bit and see what it does. Okay, it's swinging. At this stage I can see it goes to 5 mils to the left and 5 mils to the right. Alright, what I'll do is I'll stop the camera now, because this will go too long, this video, so I'll stop it and I'll come back in another 10 minutes. The time is 19:07 and it's swinging equidistance between the 99 and the halfway point between 1 and 2. Maybe slightly, no, it's too early to call yet, so we'll come back in another 10 minutes. So it's now 19:11. The pendulum's slowing down, so I thought I'd capture this now before it goes too quick. So it appears to be going, almost hitting the 90. It is hitting the 90 and not quite the 1, so that would indicate it's going slightly clockwise. Let's have a look from the clock. Let's have a look from above with my phone camera. There does appear to be a slight left to right movement, which is clockwise. Alright, I'll come back in a little bit more, but I think the pendulum is starting to lose momentum. Alright. There does appear to be a slight left to right movement, which is clockwise. Okay, it's 19:15. It appears to be slightly more left than right, which indicates clockwise. Just have a quick look with the camera on the phone. That's the swing. There's virtually zero air currents. And looking from the top, looks to be a clockwise direction. Okay, I think the pendulum has died enough. We'll do another swing to confirm it, and then it'll be it. So just looking at that cotton, there's no air movement in here. I'm fanning it now with my hand. Hardly moves. Alright, there we go for launch number 2. I trimmed some of those extra pieces off. So here we are for swing number 2. Pendulum slightly oscillating across that centre line. It shouldn't make much difference. So just looking at that cotton, there's no air movement in here. I'm fanning it now with my hand. Hardly moves. Alright, there we go for launch number 2. I trimmed some of those extra pieces off. One minute in. The laser is still, the only error now is the laser is still shaded by the thickness of the 1mm suspension cord. So alright, let's come back in another 5 minutes. The time is 19:26, so it's 19:29. Let's get another shot of the top. Pretty much going along the laser at the moment, as steady as I can hold it. It should also be showing on the other camera. Should be seeing equidistance on the other camera. Yes, appears to be equidistance either side of that laser. Alright, I'll come back a bit longer, but the pendulum is still got plenty of momentum. Just get another shot of the from the top. Pretty much going along the laser at the moment, as steady as I can hold it. It should also be showing on the other camera. Should be seeing equidistance on the other camera. 19:35. Possibly a slight more to the left than the right. I'll look from above. It'll be very hard to pick that. Very hard to pick. Maybe either right on the line or slightly left of it, slightly clockwise. very hard to pick. Maybe either right on the line or slightly left of it, slightly clockwise. $19.39. The pendulum's dying pretty quickly here now. I don't think we'll get an accurate result on this run. And it's still following the line, the laser. Okay, I think we'll give it a miss for this. Maybe one more run, a third run, and just see what happens on the third time. So here we go. Launch number 3. $20.36 is the time. 48 seconds into launch. The error is still within the thickness of the suspension cable, which is 1mm. Two minutes in. Maybe equidistant still. Slight. We've jumped either side of the cable. Alright, I think I'll stop the video and come back in about 5 minutes. 2043. 2044, sorry. Alright, seems to be no difference in the swinging equidistance. Okay, we'll come back again. 2049, equideviation. The pendulum is actually reduced in amplitude quite significant. I'll give you a shot on the phone camera. Okay, so I think it's in this stage it's lost enough momentum that it can't really do an accurate measurement. Looking at the top. It's tracking that laser line pretty much as the other camera indicates. Alright, I'm back to the other camera now. I think that's a wrap. There's So the results of this experiment were, the first experiment slightly gave a clockwise direction. The last two gave gave zero deflection, and I can say safely that the launch indicator only moved a few degrees off its launch direction, so I don't think I'm experiencing any bias. We have recaptured or simulated the pendulum in France, which is our 7:1 ratio. I can't think of anything else that we could have missed. Well, apart from the fact that most during the 1851 to 1852 era, you can imagine there was hundreds of thousands of these pendulums made, and many of the results were getting what I was getting. The more precise ones were indicating no deviation from the Earth, but that's not to say they were accurate. We don't know, there's no recorded instance of them. This pendulum is I've gone as further than anyone has gone, I believe, with this pendulum and its accuracy. So there's still further to go before we make a call. So at this stage here you would make a call and you would say that the Earth is not influencing the pendulum, which would mean that the Earth is not spinning, which then takes you to the next stage, the Earth is flat. So I'm not prepared to make a call. I think more experimenting, more precision. So I think I'll take up our advice from the last lot of comments indicating that I should swing on the east-west direction now, just to make sure that there's no bias, because right now I could have a centre bias that I'm not detecting. So let's go east-west and see what happens on the next that'll be 12C. Alright, thanks for watching, and see you in the next video.